Hello all. In today's session we will talk about feed forward process. Till now we have understood how to stack perceptrons in layers, connect those perceptrons with the weights and then perform the weighted sum and finally apply activation function to that weighted sum. Now let us combine all these points together and implement in a forward pass calculation to produce the predicted output. So a training neural network, that is MLP model, will perform operation in three main steps. You have feed forward process. Feed forward process, we calculate the error, that is I get the predicted output here, and how far this predicted output is equal to my true value will be done by calculating error. Once the error is calculated, if error is found to be as high, we will back propagate and optimize the weights so that error gets reduced. So these are the three main steps involved during a training of artificial neural network. So we will look into the feed forward process first. The process of computing the linear combination and applying the activation function is called as feed forward process. The term feed forward is used to imply the forward direction in which the information flows. For example, I have two hidden layers, one input layer and one output layer. I'll try to feed the input starting from the input layer, passing through the hidden layers, and finally I'll get the predicted output. This is called as feed forward process. Once the output is predicted, I try to calculate the error by subtracting true value minus predicted value, and if this error is found to be as high, I'll do back propagation algorithm where I will update the weights and repeat the process of feed forward pass. So this is my feed forward pass. I calculate the predicted output, calculate the error to find how the model predicted value is same as that of true value or not. Once the error is found to be as high, I'll back propagate by updating the weight, and once the weights are updated, again I'll repeat the process of feed forward pass. Consider a simple 3-layer neural network as shown below. You can see here, this is my input layer, this is my output layer, and two hidden layers here. So it is a 3-layer network, one input, one output, and two hidden layers. It has layers, it has weights and biases, activation functions, as well as node values. Node values are nothing but what? Neuron values. Now let me consider first input with the first hidden layer and try to calculate the outputs of A11, A21 and A31. Here in the superscript you have one that represents first layer, and this 2 represents second layer, and 3 represents third layer. So I have x1 given as input to A11 with weight W111 and x2 as W12 and x3 with weight W13. So my output at A11 will be sigma of, why did I write sigma of weighted sum Wx, apply activation function, what we have done in perceptron. Find the weighted sum and then apply the activation function on the final output. Similarly, you can see here sigma of what are all the inputs coming to A11. I have x1 with W11, x2 with W12 and x3 with W13. Similarly, A21, I have x1 with W21, x2 with W22 and x3 with W23. So sigma of weighted sum of all the inputs associated with the second node of first hidden layer, similarly third hidden layer. So similarly, we try to calculate the outputs of the nodes of layer 2, and in layer 2 I have 4 nodes A1, A2, A3 and A4 respectively. Finally, I calculate the output, which is my predicted output, which is A13 is equal to sigma of, you can easily calculate that, A13 is equal to sigma of A12 into W11, A22 into W12, A23 into W13 and so on. So you got the predicted final output here. Now you can see here that for such a simple 3-layer network, we had to solve many equations. What if I have more complex network with hundreds and hundreds of neurons? In such case, to make the calculations more efficient, we can make use of matrices which can be easily implemented with one line code when using NumPy. So let us see how matrices computation looks like. Predicted output is equal to third layer sigma of W3 multiplied by second layer sigma of W2 sigma of W1 first layer multiplied by the input vector. That is, I am multiplying input vector by the weight and then applying the activation function. Converting it into matrix form, I have y hat is equal to sigma of y3. What does this 3 represents? It represents layer 3. In layer 3, I have how many weights? W11, W12, W13 and W14, and only at the one node. So one row I will get. Similarly, weight at the second node. At second node I have at second layer I have 4 nodes. This is the first node, second node, third node and fourth node. In the first node, what all weights are connected? W11, 12, 13, 21, 22, 23 and so on. Similarly, at the first layer, first hidden layer, I have all these weights associated to node 1, node 2, node 3 respectively, multiplied by the inputs x1, x2 and x3. So the best way to read this equation is start from the right to the left. X1 multiplied by W1 into sigma multiplied by W2 into sigma multiplied by W3 into sigma. Now, so far we have learned how to implement forward pass in neural network to produce the predicted output. Now, we need to find or evaluate this predicted output is same as that of the true value or not. That is, we need to evaluate this predicted output. So, what do? We measure error. The error function measures how wrong the neural network prediction is with respect to the true value. If the error is high, then that means our model needs to be trained more, and if the error is very less, then the model is better or the model is good. The selection of an error function is another important aspect of design of neural network. So when you go for regression problems where numerical values are involved, we calculate MSE, mean square error and mean absolute error. And in classification problems where set of probabilities are mentioned, in that case we calculate cross entropy. So error generally is calculated by the formula as mod of predicted value minus the actual value. So these are the formulas to calculate mean square error. Mean of square of error and mean of absolute value of error. These both are used when regression problem. Coming to classification problem, we have cross entropy. Cross entropy can be better understood using this example. Suppose that we are trying to classify a dog image out of 3 possible classes: dogs, cat and fish. That is, given an image of a dog, I want my machine to classify this dog comes under either dog, cat or fish. So the training distribution, the true distribution is probability of that image of dog belonging to cat is 0, probability of that image belonging to dog is 1, and to fish it is 0. But what your machine has predicted, it has calculated that image of dog as under probability of cat as 0.2%, and that image belonging to dog probability as 0.3%, and that image belonging to fish as 0.5%. So this is my true value, these are my predicted values. Now how do you calculate cross entropy using this formula? E of W comma B is equal to minus summation I is equal to 1 to M y hat of log Pi. So minus the true value for my probability of cat is 0, 1 and 0.0. 0.2 is my predicted value, 0.3 and 0.5. Substituting all the values, you will get the error as 1.2. This is another example where another machine has calculated the probability of that image belonging to cat, dog and fish respectively are 0.3, 0.5 and 0.2, and here the error calculated is 0.69. That is, the error got reduced as the probabilities got increased. So if I have n number of training examples, this will be my equation to calculate the cross entropy. Minus summation I is equal to 1 to n, sigma I is equal to 1 to m, y hat of ij log of Pij. This is used for n training examples. So this is the end of today's session. In the next class, we will talk about different optimization algorithms to reduce the error. Thank you all.